Today we're going to be looking at lesson 6 of chapter 5, which deals with inequalities in one triangle. The objective is for you to be able to use these inequalities involving angles and sides of triangles. So the theorem that we're going to be applying today, okay, this isn't in your notes, but we're going to see how we can apply it, is the triangle inequality theorem, which says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay? To be able to take three sides and make it into a triangle, that has to be true. The sum of any two sides, so those two added together, has to be greater than the third. Okay? So using that information, we would have to try all three different combinations of those three sides, okay? To see if it's going to form a triangle or not. Okay? If we think, though, about the numbers that were given, we don't need to try all three situations. If we take the smaller two and add them together, it has to be greater than the third side. Okay? If that works, all the other combinations work. Okay? So we can save ourselves some time. We don't have to do all three combinations, just one combination using the two small pieces to add together. So if you open up the flap that says, is it a triangle? That is what we're going to do. So it says to determine if the following side lengths could form a triangle. So again, instead of having to write down all three combinations, we're going to add the two smaller ones together, which are the 8 and the 17. So I'm going to write down 8 plus 17. What is 8 plus 17?
Like 25 or something.
25. 8 plus 17 is 25, which is greater than 24. So this fits that triangle inequality theorem. The two sides added together is greater than the third side. So could these side lengths form a triangle? The answer would be yes. So then we look at number 2. So we're going to add the two small ones together. 3 plus 3 is how much? 6. So 6 is less than 7. So the answer is no, okay? Because of the less than. We need it to be greater than the third side for it to be a yes. So the last one here, we just need to look because they're not put in order for us. So you always need to make sure you're picking out the two smaller. So 7 plus 35, which is how much? 42. So that's greater than 41. So that would be a yes, okay, because of the greater than symbol. What do you think it would be, yes or no, if it was an equal sign?
No. Yes, maybe.
If we think about what this said, okay, any two sides has to be greater than the length of the third side. So if they are equal, it would be a no.
Why?
Because
Okay. If we think, okay, has to be greater. If I think about this yardstick, 36 inches, okay, if I broke it into two equal parts, okay, I'd have 18 and 18. Could I take this original yardstick and then two pieces of 18 and make a triangle?
no.
No, because to match up my 18 and 18, they're going to match right up on this line. They're not going to be able to stick up to get to the 18. That's why it has to be greater than, not equal to. Okay? So any two sides added together has to be greater than the third side. Then if you move to the finding a third side range flap, okay? This is using that same idea of that triangle inequality theorem. This time it gives us two sides and we want to find the third side range. Okay? The problem is with these two sides that we have, we don't know if the missing side is smaller than 3, if it's the smallest one, or it could be the biggest one, it could be bigger than 11, or it could be somewhere in between 3 and 11. Okay? We don't know the length of the third side. We're trying to find a range for those sides. Very easy to do. Okay? What we are going to do to find the smaller possible number, we're going to subtract the two numbers. So 11 minus 3 is 8. We're always going to use the less than symbol. Then we're going to put a variable. We can choose any variable we want. I use S for side, but again, you can choose anything. We're going to put another less than symbol. And then to find the upper end of the range, we are going to add them together. So 3 plus 11 is 14.
Where did we get the 8 from, though?
You subtract.
We subtracted the 11 and the 3.
So, oh, I see.
Okay.
Because if it was 8, it wouldn't work. Because it'd
Okay,
be equals.
right. So any number between 8 and 14, and we don't have the equal to bar, so we're not counting 8 and 14, but any numbers between those two would work and make that first situation that we talked about true. Okay. So we just subtract to find the lower end. We add to find the upper end. We're always using those less than symbols in between. So for number 5, what's going to be my low number? 3, less than the variable, less than 59. Okay. So subtract to find the little one, add to find the big one. So for number 6, little number is 17, less than the variable, less than 31. Pretty simple, right? Then another theorem that we're going to be working with says that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So when we look at this triangle, we're told that xz is greater than xy. Okay? So if xz is the longer side, then its opposite angle, y, is greater than the angle opposite xy, which is z. Okay?
That's a little confusing.
So if xz is the longer side,
Right.
then the angle opposite it is the bigger angle. Okay? If it gets confusing when you see those angles being, or arrows being drawn through that, okay? If we think of our triangle, we have 3 vertices, x, y, and z. So when I look at,
Just means mine.
okay, if we look at these, if I look at x and z for my side, xz, the missing letter is y. So it's the opposite, so it's angle y. If it's x side xy, we're missing the letter z. Okay? So if xz is greater than xy, then angle y is greater than angle z.
Whack.
Okay, so we're just going opposite. Okay? So if you look at your ordering angles flap, okay, that's what we're looking at here, is that theorem. So the smallest angle is always opposite the shortest side. the largest angle is always opposite the longest side. So that's what that theorem told us. Okay? So when I look at this triangle, I know all three side lengths. They're asking me to order the angles from least to greatest. Okay? I don't know my angle measures, but I can still put them in order. I'm not going to say how big they are, but I can say which one's the biggest, which one's the smallest, using this information. Okay? So they want me to list the smallest angle first. Okay? My smallest angle is going to be opposite the shortest side. Okay? So it's this one here is the shortest side. That's side BA, which means angle C is going to match with that. Oops, not 2. Angle C. Then as I get bigger, the next one would be the 20 meters. BC, opposite is angle A. And then I'm left with angle B. So again, I can't say the size of the angles, but I can put them in order from least to greatest, or from greatest to least. So we always need to read carefully so we get them in the correct order. Okay? Same thing happens in the other direction. Okay? If two angles of a triangle are not congruent, then the longer side is opposite the longer angle. So we can still use that same thought process. If it's angle A, we're talking about side BC. We're using the other letters. If we're talking about angle B, it's opposite of side AC. So, working in that opposite direction with this theorem. So, if you look at your ordering sides flap, the shortest side is always opposite the smallest angle. And the longest side is always opposite the largest angle. So with this example, they want me to order the sides from greatest to least. I don't have any information about the side lengths. But again, I can put them in order by looking at my angle measures. Before I can do that, though, I need to know the measure of angle D. How big is angle D?
68. Well, we can find out by taking 180 and subtracting by 59 and 53.
Okay. So I heard somebody throw out the number 68. Simon says that we could subtract the 59 and the 53 from 180 because we know that the three angles in a triangle have to add up to 180. Okay. 68 is correct. Okay. And just like Simon said, we could subtract the two we know from 180 because we know three angles in a triangle add up to 180. Okay. I'm going to show you another trick. Friday when I showed it to third period, they were like, why didn't you ever show that to us sooner? Okay. It can work anytime. It works pretty easy here because we're close to being an equilateral triangle. What do we know about angles in an equilateral triangle?
60.
They're all 60 degrees. Okay. And 60 times 3 equals 180. Okay. This one is missing a degree. If it's missing a degree, it needs to be made up over here. This one is missing 7 degrees, so it needs to be made up over here. So 60 plus 1 plus 7 gives me 68. Okay? So again, just another way to think about that. Okay? But again, it works pretty easy with this one because our angles are all close to 60. Okay? So now that we know those angle measures, we can put the sides in order. We want to start with the greatest, the longest side. So that's opposite the biggest angle. So angle D, we use the other two letters. So it's EF. A side is a segment, so we want our segment bar across the top. Next length is opposite angle E. So we're using the letters DF. You can have the two letters switched around. And then we finish with DE. So all we're being able to do is compare them. We're not being able to assign actual lengths or measures of the angles, but we can put them in order from biggest to smallest or smallest to biggest using this information. Okay? And that is it for this lesson.